everyone, welcome back to Conquering Algebra 2. This is lesson 36. In this lesson, we're going to talk about multiplying rational expressions and dividing them. The important thing that you have to remember before you can even begin to attempt these types of problems is taking trinomials and factoring them into two binomials. Don't forget to factor out greatest common factors and things like that. So that's the first step. For all four of these parts, we're going to factor them into binomials. So I'm going to go ahead and write our fraction bar, multiply, and the other fraction bar. Okay, and so we know that all of these are going to have two sets of parentheses because they're all trinomials. Okay, so in this first one, we know that the only way we can get x squared is to do x times x. Now, when multiplying 12, I can get 1 and 12, or 2 and 6, or 3 and 4, because it's saying negative 12. That means we are subtracting these. So that would be 11, 4, and 1. So because this is just x, that means I want 3 and 4. But we have to figure out the sign. When I'm multiplying and getting a negative, the only way that happens is if they have different signs, 3 and 4. And since x is positive, that means the larger number will get the positive. So that would be negative 3 and positive 4, which we've already been doing that for a while. So now we're going to do the same thing with the denominator. We have x and x with 20. It could be 1 and 20, 2 and 10, or it can be 4 and 5. And again, given that this is a 1, we're going to pick 4 and 5. And since x is negative, the bigger one keeps the sign. So there's the first fraction. Now we're going to do the same thing on the other side. So we have x and x. Another important thing I want to note before we finish this is that none of these four trinomials have a greatest common factor that we're taking out. That's why we're just jumping straight into our binomials. If there was a greatest common factor, we would take that out first and then factor it into our binomials. 35 can be 1 and 35, or 5 and 7. We're going to pick 5 and 7. And since this is a negative, that means they're going to have different signs. 2 is positive, so we pick like that. And then with 14, I have 1 and 14, or 2 and 7, and we're going to pick that one because we're looking for 9. 14 is positive. That means they're going to have the same sign, my 2 and my 7. Which sign is determined right here. So since 9 is positive, they're both going to be positive. Okay, so we've done all the factoring. Now at this point, we just treat this like any other multiplying fractions problem. We're going to look to cancel before we multiply. So I noticed that here I have x plus 4 and x plus 4. One is in the numerator, one is in the denominator, so I can cancel them out. I also noticed x minus 5 and x minus 5, so I can cancel those out. And I also have x plus 7. So the only thing left in my numerator is x minus 3. And the only thing left in my denominator is x plus 2. This is my answer. Once I'm done factoring and canceling, this is all that remains, so this is our answer. Our second concept is going to be dividing. So the only thing that's going to change is we're not starting out with the multiplication, we have division. And we know that when we are dividing fractions, we're going to change this division sign to multiply, and we're going to flip the second fraction. So the first one stays the same. Still going to be x squared minus 6x plus 8 over x squared plus 3x minus 28. And then here is where I have to remember to flip. So x squared plus 2x minus 35 over x squared minus 2x minus 15. Okay, so from here, my next question is going to be, do any of these possess a greatest common factor that I need to factor out? None of them do, so I'm just going to start factoring into binomials. Okay, so in our first numerator, we know that the only way we can get x is to get x squared is to do x times x. And then with 8, we have 1 and 8, or we can go with 2 and 4. 2 and 4 is going to get me 6. Okay, so the 8 is positive, that means they're both going to have the same sign, and since 6 is negative, that means they want to both be negative. With our denominator, we have x times x. For 28, we could do 1 and 28. We can do 2 and 14, or we can do 4 and 7. And 28 is negative, so we're subtracting them. When we subtract, we want to get 3. So we're gonna go with 4 and 7. So multiplying to get a negative, they're gonna have different signs. 3 is positive, so the bigger number, my 7, will get the positive, meaning the other will become negative. So right now I can already see that I'm gonna be able to cancel that out in just a moment. In our second fraction, we're gonna make sure we're looking at this one and not at the top because we had to flip the numerator and denominator. So we're gonna have x and x. For 35, I have 1 and 35, and then I have 5 and 7, and we're subtracting them, so we're gonna pick 5 and 7. And since 2 is positive, the 7 will get the positive, and 5 will become negative. With the denominator, we're gonna do x and x. We can do 1 and 15, or we can do 3 and 5. We're subtracting them, and we wanna end up with 2, so we're gonna pick 3 and 5. And since 2 is negative, 5 will be negative, and 3 will be positive, because that will equal -2. So now we are ready to start canceling where we can. So we already noted earlier that we have x minus 4. We also have x plus 7, so those are gone. We also have x minus 5. And all that's left is x plus 2 over x plus 3. And sorry, this is supposed to be a minus. So x minus 2 over x plus 3, this is as simplified as it gets, so we're done. Our second example in this part, or in this concept, they do have a greatest common factor that we need to factor out. We can do that in the same step as when we flip this numerator denominator. Since it's saying divide, we have to change it to multiplication anyways. So this first numerator, it's not going to change. It'll still be x squared plus x minus 6, but here we see that all three terms can have an x factored out, and what is left is x squared minus 2x minus 35. Okay, so in our second fraction, we are flipping it, but we also see that right here, they both have an x that can factor out. So this will become x times x minus 7, and then our denominator, our new denominator, there's nothing to factor out there, so it just stays put. I'm gonna put parentheses here just so I can remember that it is one term together, just whenever we get to the canceling phase of this problem. So by taking out the greatest common factor, this second fraction, it's good to go. It's ready to be done, but we still need to fix this first fraction and get those into binomials. So that's gonna be our next step. Okay, so this first one, we're going to have x and x, and then 1 and 6, or 2 and 3, we're subtracting them, so we're gonna pick 2 and 3. And then 3 is gonna get the positive, 2 is gonna get the negative. This x has already been factored out, so it's gonna stay outside. To get x squared, we say x times x, and then for 35, we can say 1 and 35, or we can say 5 and 7. We're subtracting them, so we're gonna pick 5 and 7. And then they're gonna have different signs. 2 is a negative, so 7 will be negative and 5 will be positive, and now we are ready to cancel. So looking at this, I have an x in my numerator and my denominator, so I can cancel those out. And then we have x minus 7 as well, but that's about it. Notice that this one says x plus 3, this one says x minus 3, so those can't cancel out because they have different signs. So what is left is x minus 2 times x plus 3 over x plus 5 times x minus 3. And this is as simplified as it goes. I would not redistribute this out. That's just creating extra work that's unnecessary. It can't be simplified, we leave it like this. All right, and that's it for lesson 36, multiplying and dividing rational expressions. The biggest thing to remember is first step, take out that greatest common factor if it's there, and then your second step is just to factor into binomials. If you're still needing help with that concept, there's gonna be a link below in the description that will help you go back to that lesson where we talked about how to factor in trinomials into binomials. So I hope this was really helpful for you guys. If you have any questions, leave a comment below. I'd love to be as helpful as I can. And to my Algebra 2 students, I'll see you guys in class.